Hello students, welcome to my channel. In this class, I am going to teach you bijective function and to find the inverse of a bijective function. Let us start the topic. Bijective function, also known as 1 on 2 function. So bijective function is also known as a 1 on 2 function. Our first problem is prove that if maps R to R given by fx is equal to x cube minus 11 is bijective. And also find f inverse. So we have to show that the function f maps R to R given by fx is equal to x cube minus 11 is a bijective function, and we have to find f inverse. Now let us start to prove this. Let x comma y belongs to domain R. Such that fx is equal to fy. So this implies x cube minus 11 is equal to y cube minus 11. This implies x cube is equal to y cube, x is equal to y. So what it shows? This shows that the function f is 1. So here we can write to show f is 1. So we have proved the function f is 1. Now let us proceed to prove the function f is on 2 function. So in order to show the function f is on 2, what we have to do? We must show there exists an element in range R for which we will get an image in domain R under the function f. To show f is on 2. So in order to prove f is on 2, select y, let fx is equal to x cube minus 11 is equal to k. So this gives us x cube is equal to k plus 11, which gives us x is equal to k plus 11 to the power 1 by 3. Now f of k plus 11 to the power 1 by 3. This is equals to, we have taken fx is equal to x cube minus 11. So this is equal to k plus 11 to the power 1 by 3 to the power 3 minus 11. So this is k plus 11 minus 11 is equal to k. It means what? For k plus, for k belongs to range of R, k belongs to range of R, we find an element k plus 11 in a domain of R such that for this element under the function f is related to k. This shows that f is 1, 2 because for each k belongs to, as for k belongs to range of R, k belongs to range R, there exists an element k plus 11 to the power 1 by 3 belongs to domain R, such that under the function k plus 11 to the power 1 by 3 gives us k. So that is why the function is 1, 2. Now the function is both 1, 1 and 2. So f is both 1, 1 and a 1, 2. Implies f is bijective. Now to find f inverse. So let us proceed to find f inverse. Let fx is equal to x cube minus 11 is equal to y. Now fx is equal to y, x cube minus 11 is equal to y. So this gives us x is equal to f inverse y, and this one gives us x cube is equal to y plus 11, which implies x is equal to y plus 11 to the power 1 by 3. So let us take this is equation 1 and this is equation 2. From 1 and 2 we get f inverse y is equal to y plus 11 to the power 1 by 3. Or we can write replacing y by x, f inverse x is equal to x plus 11 to the power 1 by 3, which is the inverse, required inverse. So our first problem is completed. Now let us proceed to solve the second one. So that fx is equal to ax plus 5 is bijective where f is a function from R to R. So our second problem is so that fx is equal to x plus 5 is bijective where f is a function from R to R, a belongs to R and a not equal to 0. Proof. To show f is 1, 1. Let x comma y belongs to domain R. such that fx is equal to fy. Fx is equal to fy. So this implies ax plus 5 is equal to ay plus 5. So this implies x is equal to y. This shows that the function f is 1 because we have started with f of x is equal to f of y implies x is equal to y. To show f is onto let fx is equal to x plus 5 is equal to k. This implies ax plus 5 is equal to k or ax is equal to k minus 5. This implies x is equal to k minus 5 by k minus 5 by a. Now, a of k minus 5 by a is equal to a k minus 5 by a plus 5. So this is k minus 5 plus 5 is equal to k. This shows that for k belongs to range of R, there exists an element k minus 5 by a belongs to domain of R under the function f. So f is onto, hence f is bijective. To find f inverse. So now let us proceed to find f inverse. Let y is equal to fx is equal to ax plus 5. So this gives us fx is equal to y, ax plus 5 is equal to y. So this gives x is equal to f inverse y. Take it equation 1. From this equation we get ax is equal to y minus 5. Implies x is equal to y minus 5 by a. So this is 2. Now from equations 1 and 2, from 1 and 2 we get what we get now. We get f inverse y. So now from equations 1 and 2 we get f inverse y is equal to y minus 5 by a. Replacing y by x we get f inverse x is equal to x minus 5 by a, which is the required inverse that we have get here. So in this way we can find the inverse of a function if it is bijective. So this class is completed. In my next class I will meet you with a new topic. Till then, goodbye.